In this question, we need to drag and drop the characteristic boxes in the middle and match them with the appropriate functions on the two sides. You'll notice that there are more boxes on the outside than characteristic boxes, so a couple of them will be left vacant. If we start with the function y is equal to negative 2x squared plus 2, this function can be thought of as being in both vertex form and general form. In vertex form, our a value would be negative 2, our p value would be 0, and our q value would be 3. In general form, our a value would be negative 2, our b value would be 0, and our c value would be 3. Let's think of it as being in vertex form, and when we do, we'll see that our vertex is at the ordered pair 0, 3. Since there is no box, we'll leave it vacant. The next equation is clearly in vertex form, which means that it would have a vertex at 3 and negative 2. Next, because this equation can be thought of as being in general form, we know that the y-intercept is at 3. The y-intercept for this equation is a little bit more complicated to determine. We can determine the y-intercept by substituting in a value of 0 for x. 0 minus 3 is negative 3, negative 3 squared is 9, half of 9 is 4.5, and 4.5 minus 2 is 2.5. Next, let's determine if our function is opening upward or downward. Because the leading coefficient is negative, the graph is opening downward. This function has a positive leading coefficient, so it must be opening upward. Next, our compression or expansion factor. This graph is being expanded by a factor of 2, and this one is being compressed by a factor of 0.5. Next, let's deal with our axis of symmetry. The axis of symmetry is always the x value of your vertex. The vertex here was at 0, 3, so it would be x equals 0. Seeing as we don't have one of those, we'll leave it blank. The vertex here is at 3, 2, so we would have x equals 3 as our axis of symmetry. Next, we need to deal with the form. Now, the form on the right-hand side is clearly in vertex form, but it could be argued that the one on the left-hand side is in both forms, so we'll put the general form over there. Let's check our solution, and we are correct.